Let's look at how to solve an absolute value inequality. When solving our absolute value inequality, we want to start by getting the absolute value of the expression on the side of the inequality by itself. Here we have the absolute value, and then we have a -2 after it. Here's the inequality sign, and there's the other side. So our first step for this type of problem would be to add the 2 to both sides, so that we have the absolute value on a side by itself. That would give us the absolute value of x minus 5 over 4 is less than or equal to 7 plus 2, which is 9. Now what we're saying is that for the values of x that we're looking at, if we took those x values, subtracted 5, took that value, divide by 4, the overall answer that we would get in there has to be a number whose absolute value is less than or equal to 9. So from 0, you think it's got to be 9 units away from 0 either side, as well as the possibility of being less than 9 units away. So that would mean that this expression needs to meet both the requirements that it's less than or equal to positive 9 and still greater than or equal to negative 9. We're going to write that compound inequality. So we have our x minus 5 over 4 is less than or equal to 9. And it also has to be true that our x minus 5 over 4 is greater than or equal to negative 9. And that makes sure that it stays within that requirement of less than or equal to 9 units away from 0 for our expressions. Now once we've written these inequalities without the absolute value, we can solve them individually. For this first inequality, we want to get rid of the fraction. So we'll multiply both sides by the lowest common denominator, which is 4. On the left-hand side, the 4's will cancel, so I get x minus 5 is greater than or equal to negative 36. And then we will add 5 to both sides to get the x on a side by itself. And we get x is greater than or equal to negative 31. But it also has to be true, so we're going to say and. This x minus 5 over 4 has to be less than or equal to 9. So again, we're going to remove our fraction by multiplying both sides by 4. We get x minus 5 is less than or equal to 36. And then when we add 5 to both sides, we get x is less than or equal to 41. Now that's our compound inequality solution. But we also want to make sure that if they ask us to graph the solution set, or if they ask us to give the interval notations for the solution set, we have those available too. So let's copy this compound inequality solution set up at the next part, and then talk about how to get the graph and the interval. We have x has to be greater than or equal to negative 31, and it also has to be true that the x's are less than or equal to 41. To visualize this and thinking about what it means to say and means it has to be both of those things. So what you can do is you can set up your number line. We look at the numbers that we have. Negative 31 is a smaller number than positive 41, so we know it's going to be further to the left on the number line than 41 is. I'm going to graph each pieces of this inequality above where I'm going to put my final solution so that I can visualize what I need to do for my answer. The numbers that are greater than or equal to negative 31 will have a bracket at negative 31 because of the or equal to. And those numbers that are bigger than it are to the right of it, so we'll shade to the right. And there's still more with this compound inequality. The numbers have to be less than or equal to 41. So we have a bracket of 41 because it has the or equal to. And the numbers that are less than 41 are to the left. Now because it's the intersection of these two sets. It's the place where they both are. So when I visually look, only one of them is way over here. When I get right at negative 31, I have both shadings. And all the way, both shadings until I hit at 41. And then after that, just the one shading again. So the only place where both requirements are met are bracket at negative 31, shade between negative 31 and 41, and bracket at 41. So here is the graph of our solution set. And once we graph the solution set, writing the interval notation is pretty much just transferring the information off the graph. As we look from left to right, the smallest number that starts to be considered for our solution set is negative 31. But negative 31 is included in the solution set because we had the or equal to. And we show that by a bracket on the graph. And we also show that by a bracket when we start our interval notation for that endpoint. Now we want to include all the numbers growing from negative 31 until we get to 41, and we represent that just by a comma and then listing the bigger number. So that means all the real numbers in that span, starting at negative 31. And then at 41, we also want to include it in our solution set because it had the or equal to. So we showed that as a bracket on the number line, and then we showed that as a bracket on our interval notation. So here are all the three formats for the answer. We have the compound inequality answer, we have the graph answer, and then we have the interval notation. And with this compound inequality, we could have rewritten it as a double inequality if your instructor likes that. When we think about saying what we could do for a compound inequality when the graph is consistently between and possibly including the numbers like this case, is we could write it with the negative 31, and now negative 31 is to the left of our shading, so that's less than or equal to our numbers, but our numbers also have to be less than or equal to 41. So this double inequality is just more of a concise way of writing that compound inequality. And those are the different ways they might ask you to present the answer.